it's Mrs. Hookstra working on Module 1, Lesson 9 on page 33, representing proportional relationships with equations. All right, let's write our EQ like we always do. Okay. Our essential question of the day, I like to have it in red, as you know. Almost the exact same one as we did for Lesson 8. How do we write an equation for a proportional relationship? And if you were paying attention in Lesson 8, you will know probably how to do this already. How do we write an equation for a proportional relationship? Jackson and his grandfather constructed a model for a birdhouse. Many of their neighbors offered to buy the birdhouses. Jackson decided that building birdhouses could help him earn money for his summer camp, but he's not sure how long it will take to finish all of the requests for birdhouses. If Jackson can build 7 birdhouses in 5 hours, write an equation that will allow Jackson to calculate the time it will take him to build any number of birdhouses, assuming that he works at a constant rate. All right? We're going to say that he does this at a constant rate. But that is constant. So in other words, our constant of proportionality, right? We're going to keep track of the number of birdhouses he can make in the amount of time that he has, right? And I'm going to use the letter B for birdhouses and T for time. Just kind of makes life easy for me. So in other words, my constant of proportionality, what was the number of birdhouses? Yeah, I could do 7. And how much time? It says 5 hours, right? And if you wanted to figure out, well, how many is that per hour, right? How many is that per hour? So take 7, divide by 5 on your calculator, and you're going to get 1.4 birdhouses per fraction bar hour. 1 hour, right? You can do 1.4 birdhouses in an hour. Well, or if we wanted to, we could do it the opposite. How much time per birdhouse, right? Hours per birdhouse. So we would do 5 divided by 7, and we could get what? I'm going to just kind of round it because it's not perfect. It's actually a repeating decimal, but the digits, it takes so long for you to find the repeat. So let's go with 0.71 hours per birdhouse. Right? Almost 3/4 of an hour, a little less than 45 minutes, basically, for every birdhouse. All right. How many birdhouses can Jackson build in 40 hours? How many can he build in 40 hours? I know the time. The question is, how many birdhouses will he be able to do, right? So what I'm going to do is I'm actually going to take this equation right here, and I'm going to change it like I did in Lesson 8. All right. In Lesson 8, I took the constant of proportionality and I multiplied both sides by that denominator, that number in the bottom, right? And then I said, hey, those two canceled out, and I'm left with the constant of proportionality times the time, and it's going to give me my number of birdhouses. Well, my constant of proportionality in that problem from up above, right? That's this one here, was 1.4. And then my time was given to me just now in the problem, so I'm going to drop that in there, times 40. And then I just grab my calculator, and I find out that he can make 56 birdhouses in 40 hours. Right? Works a full work week. And he could get 56 birdhouses made. How long will it take him to build 35? Let's suppose he only has an order for 35. Only. That's still a lot of birdhouses. So this time, I'm going to take the other equation, right? I'm going to take the other equation, and I'm going to work with that one. And this time, what I'm going to do is I'm going to take the time divided by birdhouses, and I'm going to multiply both sides by the number of birdhouses. Again, when I do that, over here, these two will cancel each other out because I'm just taking birdhouses divided by birdhouses, that same number over itself, and they cancel each other out. So the number of birdhouses times the constant of proportionality is equal to the time. And again, now I'm using the second part of that equation, right? So I'm going to take my 35 birdhouses from my problem times my constant of proportionality that I just had a second ago in that second equation up above, 0.71, and I can calculate how much time it's going to take. So I typed it in on my calculator, and it's going to take him 50.7 hours. I don't know how long 0.7 of an hour is. That's kind of a weird thing to me. Oh no, I apologize. I did that math problem wrong. Just erase that part there. That one's 25. That makes way more sense to me. There we go. It just didn't make sense. 25 hours. Okay, now let's do the last one. How long does it take to build 71 birdhouses? 71 birdhouses, time, right? We're looking for the time. So which of these equations do I want? I'm going to use the one that I just used right above up here. Time is equal to the number of birdhouses, in this case 71, times the proportion, the constant of proportionality, which is 0.7. Now this is where I get that 50.7 hours. There we go. And I don't know what 0.7 of an hour is. I know this is 50 hours plus 0.7 times, if I do 60 minutes, I can figure out how long this is. So it's going to take them 50 hours and 42 minutes. 50 hours, 42 minutes to make 71 birdhouses. All right, flip over the page. Let's go to page 34. Page 34, we have got Al's Produce Stand. Al's Produce Stand sells 6 ears of corn for $1.50. I love fresh corn from the farmer's market, $1.50. But Barbara's Produce Stand, she sells 13 ears for $3.12. It says write 2 equations, one for each produce stand that models the relationship. So let's just talk about Al's Produce Stand first, right? Let's just deal with everything with Al. We'll deal with Barbara in a minute. All right, so Al's Produce Stand, 6 for $1.50. We already have that in that table, right? So what is his constant of proportionality? Well, cost is Y. The number of ears that you're buying is X, because the cost depends on how many ears of corn you're buying. So we're going to have it set up that way. Let's find our constant of proportionality. Right, we're going to take cost and put it over the number of ears. Our cost is $1.50 for 6 ears of corn, or 25 cents for 1 ear. Right, 25 cents for 1 ear of corn. Well, now I can use that to figure out 14, 21, all the other numbers. Okay? So let's stay with this, and we're going to go y is equal to kx. That's the equation I'm going to use. That's me changing up that constant of proportionality equation like I did in lesson 8. And I know y is equal to, this is my constant, right, 25 cents. X are all those numbers, 6, 14, 21, all those. So I'm going to multiply by 14. And I find the answer to be $3.50. $3.50 go in there. Well, let's do it for 21. Y is equal to 25 cents for 21 ears, right? You got a big family coming over, having a party. How much is it going to cost for all that corn? It's going to cost you $5.25. Well, let's suppose you're having a huge party, like the whole neighborhood's coming, right? And your parents say, here's $50, go get corn. How many ears of corn could you get with $50? Wow. Well, if you notice, the $50 is in the Y section, right? It's here. So that means I'm going to put the 50 where the Y goes on my equation. $50 is equal to the 25 cents times the number of ears that I'm getting. I don't know that, so I'm going to put that in as X. So since these two numbers, 25 cents and X, are being multiplied, right? Those are being multiplied. So I'm going to divide them. I have to do the opposite of whatever is currently going on over there. So I'm going to take my 50 cents, or $50, divide by my 25 cents, and I find out I can get 200 ears of corn. Wow, for $50. All right, good job. Let's try it for Barbara's produce stand, right? Who has the better deal? Whose is better? So I go over here to Barbara's, and I'm calculating hers. So let's find her constant of proportionality. Again, we're going to do the cost over the ears, just like we did the last one. We want to be consistent when we do these problems. Otherwise, we're not comparing like things. So I take this and I go, the cost is $3.12, and I'm going to divide that by the 13 ears, and her constant of proportionality is 24 cents per ear. All right? She's a penny cheaper for every piece of corn. Well, a penny, you're like, what's the big deal? Well, let's suppose that they have the same tasting, good tasting corn, so it's not a matter of who's got a better quality. My equation for this one's going to be y is equal to 0.24x, right? Ales, on the other hand, was 0.25 times x. All right, so we calculate Barbara's over here. You're going to buy 14 ears. So how much is it going to cost? Y is equal to 24 cents times the 14 that you have to buy, right? And we get $3.36. Just a little bit cheaper. All right, let's do it for 21 ears, right? We're having the same party, same group over. 24 cents times the 21 people, and I get $5.04. You know, that's not significant. It's not a lot, but it does start to add up if you have a really big party, right? Now notice again, this one is our Y, and I want to know how many people are going to be able to eat corn for $49.92. So $49.92 is equal to 24 cents times the number of ears that we need. To solve that, I have to divide by 24 cents on both sides. Right? When I do that, I find out I can get 208 ears of corn. Okay, I can get 208 ears of corn. I can get more corn for less, obviously, if I go to Barbara's. All right, guys and gals, I hope you have a great day, and I will see you all later.